And he's almost done there. You ready to go?
Mm-hmm.
Okay, cool. All right, so this is the only time you have to look in the camera. Go ahead and introduce yourself.
I'm Jareen Roderick. I teach at Waubonsee Valley High School in Aurora, Illinois. This class is sophomores and juniors in an honors pre-calculus class. We're doing a unit on modeling.
Great. Okay, so ready for this?
Mm-hmm.
And you can use your notes again at any time. So first, bunch of questions. They're saying, we want to understand the decisions you made in planning for this lesson and how it fits into the unit and year. First question, how does this lesson connect to and build on students' prior skills and knowledge?
Okay, this unit is done, we've decided to do this a little bit differently this year. Typically, modeling is done at the end of the study of linear functions, our power functions, our exponential, logarithmic, whatever topic it is. This year we decided to throw in to recreate that where we, after we've studied all of those types of functions, we're just going to give them data and then let them assess which model is most appropriate. And we're trying to have them use the tools that one would use in statistics, where they assess the value of R and the residual plot in determining which is the most appropriate model. In stats, which is another course that I also teach, we talk about the fact that all models are wrong and some models are useful.
Okay, great. What was taught before this lesson and what will come after it?
We just finished the unit in exponential and logistic functions, studying those. Prior to that, we had done trying to remember. I can't remember. Okay, what did we do before that? We have to start that one over.
Okay, no problem. What was taught before this lesson and what will come after it? Discuss the sequence of the lessons that surround this one lesson.
Oh, okay. Just this lesson. Got it. Okay. Just prior to this lesson, we finished studying exponential and logistic functions. Since they've already seen the linear and power and logarithmic functions earlier in the year, we felt that this was a good time to do this modeling. We're going to continue tomorrow looking at the results of our assessment using the criteria of R and the residual plots, and look more into how the context fits in the situation and how we use the model then in the context to do some prediction and answer other types of questions.
Okay, good. Talk about the standards or cluster targeted in this lesson. What did you do to make the lesson reflect the full intent of the standard or cluster?
The standards that I was hoping to address in this lesson were the modeling, application, and making conjectures. Obviously, modeling was the primary objective, but I wanted them to make some conjectures based upon what they thought the meaning of R was and how it was significant in determining which model was most appropriate.
Which of the core action indicators do you think this lesson best exemplified, and how did you plan for this?
Jeez. I gotta go back to this one. Oh, jeez. Give me that question one more time.
Which of the core action indicators do you think this lesson best exemplified, and how did you plan for this? Is there just 3 of them?
Yes, and
1, 2, and 3.
yeah, I mean, I actually listed just about everything, but I noticed that they were numbered differently here than what it was when we went to the training this summer, so I think there's been some adjustments to them. So I don't know that I necessarily want to call them Do we want to call them by 1, 2, 3? What are we talking?
Which of the core action items do you think this lesson? Is there one, oh, you want to utilize all 3 of them?
Yeah.
Okay. I would just call them
Okay,
1, 2, and
I'm going to
3
go
and
with, I'm going to talk about the shifts.
Okay.
Okay, I think that the core action that was most exemplified in this lesson was the first, which is reflecting the shifts, making sure that students have conceptual understanding, the ability to apply the skills that they've learned, as well as the procedural fluency. In this case, the procedural fluency is in using the calculator.
Okay. Discuss how the lessons illustrate the shifts required by the CCSS. Would that be similar or?
Discuss how the lesson illustrates. Was
So
that
we're
in?
interested in how the shifts required by the CCSS are being incorporated into the classroom. Discuss how this lesson illustrates the shifts required by the CCSS.
Okay, I think that's in one of these things that I wrote things down. Give me that question one more time.
Discuss how this lesson illustrates the shifts required by the CCSS.
Well, I know the shifts, particular the conceptual understanding. I guess this lesson really addresses the idea of the shifts in the standards by using more of an inquiry method as opposed to saying, well, as I mentioned earlier, traditionally at the end of the unit, here's the data, find the linear model, use it to predict. Instead of that, I'd like, because when they're given data in a science class, they don't necessarily know that it's going to be linear or exponential or power. They've got to have an understanding of what's the mathematical foundation that's going to help them choose the correct model.
Okay. How did you teach the content of this lesson prior to the CCSS? What's the same and what's different?
In the past, we would have done just that. At the end of the unit, we would have given them the data and said, now find the linear model, and moved on. Now it's more of a, let's really understand the appropriateness of a model, and we'll spend some more time tomorrow looking at what we expect numerically in a linear model versus in an exponential model, looking for a common ratio for an exponential model where we would expect a common difference in a linear model.
Student engagement is crucial to the work of the CCSS. We want to understand how you ensure that all students had the opportunity to productively engage in the work of the lesson. How did the students handle this lesson? Did they understand the mathematics of the lesson, and how do you know?
One of the things that I do to make sure that my students always have, I need to start over. I don't remember the first part of the question.
How did the students handle the lesson? Did they understand the mathematics of the lesson?
The first part of it, even before that.
Okay, this is just a little intro.
Okay.
Student engagement is crucial to the work of the CCSS. We want to understand how you ensured that all students had the opportunity to productively engage in the work of the lesson.
Okay. All the students are engaged in the lesson because each one of them has their own calculator. And so they're able not to just watch what I'm doing, but they're doing it themselves. They have the opportunity to ask questions among those in their groups. And as I find that I know particular students that may have struggled, I'll check in on them to make sure that they're not having any difficulty.
Explain how you differentiated in this lesson. Did all students have opportunities to work on grade level content? If all students did not have that opportunity, please explain why.
They all worked on the same content, primarily because it is an honors class. So I feel that, I want to start over.
You want me to read the question?
Yes.
Explain how you differentiated in this lesson. Did all students have the opportunity to work on grade level content?
There was some differentiation in the lesson when some of the students knew that they were not going to be able to take the log of 0. They recognized that. And if they made the changes that someone had suggested in that second problem, that they knew that down the road they were going to have some difficulty. I let them go ahead and work that way because I wanted to see if they could work through that. And I feel for the most part they were successful in doing that, those who realized that. They knew what adjustment to make.
Okay. And then let's still part of the question. If all students did not have this opportunity, please explain why, working on grade level content.
It was almost a choice among those in the group to do that differentiation. And in essence, it actually made it a little more challenging for them, but yet, I got to start over again.
So, did all students have opportunities to work on the grade level content? Which you answered. If all students did not have the opportunity, please explain why.
Okay, they did.
They all had the
Yeah.
opportunity. Okay. Moving on.
Mm-hmm.
Which behaviors from Core Action 3 did the students best exemplify in this lesson?
The Core Action 3 behaviors, I think, that were best exemplified are the fact that the students continued to work, even if I was not leading them at the board, they were all engaged, they were working together in their groups to getting them, I gotta start that over again, so I'm so sorry. Yeah, you're coughing it.
I know.
And they bang on the computer.
Okay. Let me see if I can get it together.
I think I know what to say.
Okay.
You don't need to
You
prompt
sure?
me. Yeah.
Okay.
I think probably the best example of Core Action 3 in this lesson was the conversations that I had among the small groups, and those then that I could bring to the large group discussion, where they explained what their reasoning was, what their criteria was for choosing their models, and some surprises that they might have been finding.
Would you like to comment? They didn't submit any work. Great instructors are continuously learning. We want to understand what you celebrated in this lesson and what you would improve upon. Reflecting on the lesson, what worked particularly well and what might you do differently?
Although some of the students chose to change the X values in the second example, I think for clarity at this point, I would have had them all keep it the same way, even though it led to some opportunities for them to reflect on the fact that they could not, as I mentioned earlier, find the log of 0. That is actually part of another problem. So I think in hindsight, I would have not allowed that to go there at that point because of some of the confusion that it may have caused for some of the students.
Then, were there any surprises or unexpected student behaviors or reactions?
I was a little bit surprised that they did have some insight about the value of R, that they knew that it had to be close to 1, although I don't think that early on anybody knew that it was going to be close to -1 as well. But I was surprised that that they had already known that for the most part.
Is there anything else you'd like to share about this lesson? You answered all the questions.
Yeah, no, I don't think so.
Okay. Okay, well, they'll edit that down,
Yeah.
so that's it.
Okay.
You're done with yours.
Yay!
Sorry.
Oh my gosh.
I know,